one night, from atop a 35-foot tower, a prison guard uses his lantern, because we know that's what prison guards use, right? To catch an inmate trying to escape. The guard easily spots him because the inmate is 7 feet tall. In fact, the inmate only makes it 12 feet from the prison before the guard yells for him to freeze. And of course, he automatically stops, right? Okay. Then the guard proceeds to climb down the tower. As he descends with his lantern, the guard notices that the frozen inmate's shadow gets longer and longer. I know you've suspended reality for a moment for me here with the guard and his lantern, right? But is that something that would happen? As the guard is climbing down the tower, would his shadow get longer?
Yes.
Okay. Let x equal the height and feet of the guard as he climbs down, and let y be the height of the inmate's shadow and feet. So the first thing we need to do is to use similar triangles in the figure to set up and solve a proportion to find the length of the inmate's shadow when the guard is at the top of the tower. Okay? So similar triangles gives me what? What kind of proportion are we going to set up here? What does it look like? So maybe the height of the tower over the distance from the base of the tower. Would that work? So how tall is the tower? 35, okay. This crazy kid earlier was like, X. Well, that's true because that's what it says, right? But we know right now that he's at the top of the tower. Fair enough? Okay. Over what? What's the length from here to the bottom of the bottom of the tower to the end of the shadow? 12 plus y. Excellent. Equals what? What does that equal? If we did height and then length, then we need to do height and length, don't we? So 7 over y. How do I solve this? Yeah, you finally get to say cross multiply and it be the right answer, right? You've been trying to cross multiply all year. Now it's right, right? So when we cross multiply, we get 35y equals 7 times 12 plus y. So now it all is just about simplifying the expression, or the equation, excuse me. So 35y equals, good, 84 plus 7y. Now to solve for y, I need to subtract 7y from both sides and get 28y equals 84, where we then divide by 28 on both sides. So y equals 3. 3 what? And what does that mean? 3 feet is the length of the inmate's shadow when the guard is on top of the tower. Okay? A function that can be used to show this relationship is blah, 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 blah. Use the domain of what? Wait, why do we have to use this domain? Why can't he be higher than 35 feet? The tower's only 35 feet high, right? X is the height of the guard as he climbs down. Why is it making us stop at 7? Why? Prisoner's only 10 feet. 10? Where did that come from? 7 feet tall, right? You okay with that? Are you okay with that domain restriction? Okay. So complete the table and graph for the function. Well, get to work. Let's complete this table like we normally do. So do one and tell me what it is. What you got? Nine is 42.
14 is 12.
14 is 12. Thank you.
10 is 28.
Tennis? 10 is 28.
28 is 4.
28 is 4.
8 is 84.
8 is 84.
21 is 6.
21 is 6. And last but not least,
31
31 is
is
3.5, right?
Yeah.
7 over 2?
Yeah.
Okay. So graph them. 31 is 2, 5. 20 is 4. 21 is 6. 14 is 12. 10 is 28. Uh-oh. Did I do something wrong? I can't graph 8. That's true, right? I didn't do anything wrong. My graph doesn't even go up to 84. Okay? So we're going to freak out about that? Of course we are. Does your graph look similar to mine? Okay. So now what? Okay, we did it, right? Okay, good. Determine the function's asymptotes and explain their meaning in the problem. So first, Jonathan's telling me a vertical asymptote, and he's saying it's x equals 7. How did he figure that out? Set the denominator equals 0. X minus 7 equals 0, so x equals 7. What does that mean in the problem?
The height of the god will never go below 7.
Okay, well, 7 is right here basically, right? That's x equals 7, isn't it?
Yep.
The height of the guard. Can the guard ever go below 7 feet?
No.
Like, realistically, can he?
Yes.
But, if he does,
You can't see the shadow?
so it's gone?
No, just
You can't see the...
Prisoner.
Here's the guard standing here. The light's shining down on him. So at some point, like here's the end of his shadow, right? As he's getting lower and lower, let me just use the actual guard and the actual prisoner. How about that? Instead of a pretend prisoner. As he goes lower and lower, his shadow is getting longer and longer, right? So once he gets right here at 7 feet, you can't see the end of the shadow, right? You can't see the end. You can see the shadow. It's not like he doesn't have a shadow anymore, right? It's the fact that you can't see the end of the shadow. Okay? So how are we going to write that? If the guard goes below 7 feet, you can't see the end of the shadow. Now, this is not the actual shadow because you can't ever see him anyways unless he lets you. Right? You guys don't even know who I'm talking about, do you? The shadow? I hate all of you. No, the shadow. It was an old-time radio series like from the 1950s, and then it was a movie.
You hate us for not knowing something from the 1950s?
Shut up. It was a movie. The movie came out not in the 1950s. Somebody look it up. Look up The Shadow on your phone. I think Alec Baldwin was in it.
If it came out any good when I was young, I'm pretty sure I remember. I probably would love to see it.
Yes, ma'am. What's your question?
I have a question. Why does the guard have to be white, but the prisoner is darker?
I just make the copies. I'm very sorry. If it would make you feel better, please color in the guard. Maybe if we erase enough.
Came out in 1994.
1994, so you guys weren't even born then yet, were you?
But the pictures do look very familiar though.
Where did you take it there, Ashley?
Thanks, Ashlyn, for making it a racist paper. I appreciate that. And since I'm recording it, you have gone down in history now. Good job. Okay, so are we ready to go to horizontal asymptotes? Why does it not have one?
Because we can't factor anything out.
How do we find horizontal asymptotes?
No, that's the whole.
That's the holes. That's the removable discontinuity.
It doesn't have.
How do you find a horizontal asymptote?
Based off the reading.
The degrees. What's the degree of the top? 0. So what's the degree of the bottom? So the degree of the denominator is greater. So
0.
y equals 0. Look on your paper if you need to. Do you still have that?
Yeah, I have it open right now.
Open. Excellent. Why do we have a horizontal asymptote at 0?
Because
There's one right here.
you can't go like below the ground.
The guard cannot climb below the ground.
Unless you want to dig a hole or something.
But you're switching things up. It's the x value that's the height of the guard. That's when he's up high, right? And you're saying we can't go below ground. Well, I agree with that unless there's a trapdoor. And then he can, right? Except what we're saying is that it can't go, the length of the inmate's shadow can't get to 0. That's what we're saying, there's an asymptote there. That's what that means. Why can the length of the inmate's shadow not get to 0? The light would have to be right above him. Can the guard get high enough for the light to be right above him?
No.
Even if we pretend that the tower is infinitely high.
You have to be right.
You'd have to be right above him, right? Well, the guard's not standing on top of him. He's not arrested. He's already in jail. Or prison. Sorry. There's a difference. You know that, right? Okay, good. On purpose. So what are we going to write here for horizontal asymptote?
Shadow never.
The inmate's shadow can never reach, what do you mean never reach 0? 0 feet? Because here's the deal. He has to have a shadow, right? Who's the only person without a shadow? Peter Pan. And we know that, first of all, he sewed it back on, right? First of all, he sewed it back on. Second of all, if Peter Pan got arrested and put in prison, why didn't he fly out? I'm just saying.
And he's probably going to dream now.
And I know it's not Peter Pan because Peter Pan is not 7 feet tall. Just saying. Okay?
He's also white.
He is also white. Okay? We've made that clear. All right, so look at the second page. Any of you ever put a can of frozen soda in the freezer? Anybody know how bad of an... Shut up! A can of soda in the freezer. Anybody know that that's a bad idea?
Now I know.
Now you know? After it exploded?
If
Okay.
it's even a few.
If you leave it in there too long, it freezes, right? I mean, it explodes. Shut up about the freezing part. Can of frozen soda has been sitting in the pantry, so it's at room temperature. Before he drinks it, Joe wants to get the soda cold, so he places the can of soda in the freezer. Over the next few minutes, the temperature of the soda starts to drop. A function to model this is blah, 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 where x equals the number of minutes the can's been in the freezer, and y is the temperature of the soda in the can, in Fahrenheit. So for this function, complete the table and sketch the graph on the axes above. So those of you who did not participate in the last table, you need to participate now. Those of you who did participate in the last table, quietly fill out your table. 2 is 55. Thank you.
Is 42.5.
42.5. Thank you.
0 is
0 is 80. Thank you.
40.
8 is 40. Thank you.
That's a brother up. Can we participate now?
Nope.
10 is 38.3.
Tennis. 38.3. Thank you.
No,
12
it's 37.1.
is 37.1. Thank you. There's still some people in the room who haven't participated at all. I note that and take off points. You know that.
4 is 46.6.
4 is 46.6 or 46.7. Thank you. 36.25. Did you plot the points on the axis yet? Do that, please. Oops. It's right there. Not that one. You got some that looks like mine? Similar-ish? Use a calculator to determine the times for which the temperature of the soda is below 32 degrees Fahrenheit. What are you doing right now? I hear a lot of clicking.
Scrolling down until you see something.
Okay, so you put it into your, like a graph, and you're looking at the table? Good.
When it's like 49.
Why do you think it's 49? So below 32 would be 49? What is X when the temperature is 32? Exactly. So when X is 48, it's exactly 32. So why would you go to 49? Just because that's the next temperature?
It said 49.
Okay.
I just want it to be on it.
So what would be a better way to state that? What you got? How about X is greater than 48? Because isn't at 48.1, don't you think it'll be below 32? But if we just went right to the next whole number, 49, we've left that one out. And it wants all the temperatures, right? Excuse me, all the times. So how are we going to write our answer? So you're thinking real mathy? How should we write our answer?
When the time is over 48, the soda will be frozen.
When the time is over 48, the what?
The soda will be frozen.
Soda will be frozen.
This is why I made it 2 on
For the record, today is National Grammar Day. I'm not making that up. It's real. Okay?
Thank you, Steve.
No problem.
I just came from English. I don't need this.
Is this grammatically incorrect?
I don't know. It just doesn't sound good.
It doesn't sound good. That doesn't mean the grammar is wrong. It means our sentence or word choices are maybe off a little bit, right? Mathematically, we need to say x is greater than 48. Fair enough? Okay. Determine the function's asymptotes and explain their meaning in the problem.
X equals
So you're finding vertical first, is that what you did? And to find the vertical asymptotes, you
the denominator.
set the denominator equal to 0, so x plus 2 equals 0, so x equals negative 2. I have a problem with that. What's my problem? And I'm asking about this particular problem, not anything else.
The time.
Why do you think the time can't be negative? Are we allowed to have negative time? A couple days ago, we did Getting Hot in Here, that worksheet, right? We talked about turning the air conditioner down, and you got an answer of like -3 or -5 or something like that. And it was very obvious that it was 5 minutes before you started. Was that allowed? Yes. Why isn't this one not allowed?
Because it's the same.
2 minutes before the soda
you
wasn't
pick it
in
up.
the freezer.
2 minutes before the soda wasn't in the freezer. We don't care about that. So basically the mathy way and the English way together to say this is that while, okay, let me see.
It would be the room temperature. You would get a value, but it would be the room temperature.
Right, but remember x is dealing with the number of minutes. It's the time value, right? Not the temperature so much. So we want to say this represents 2 minutes, what? Prior or before we started measuring. But the nice way to say it, because we could say, but we don't care about this. But the nice way to say it is, it's not in our domain. Is it? Just like on the other paper, on the prison break paper, we don't care about 7 feet, 6 feet, 5 feet, 4 feet, because that's not in our domain, right? Now, we were specifically given a domain this time. This time, on this one, on frozen soda, they kind of wanted you to come up with one on your own, right? Okay? So what about horizontal asymptotes? Y equals what? Now, how'd you get y equals 30?
Because the exponents are the degrees are the same.
Oh, okay, so we look at those and they're the same, so we look there for the asymptote, right? So y equals 30. What does that mean?
The temperature won't go below 30 degrees.
Why not?
The freezer set.
That's exactly right. So on my graph, there's my asymptote, right? Ish. The temperature won't go below 30 degrees because what'd you say?
The freezer set to 30 degrees.
The freezer is set to 30 degrees. How do you know that? Have you been to the freezer?
No.
It's proof in the problem, right? It's proved, proven, proved, proof-ish in the problem. Isn't it? If it's telling us there's an asymptote at 30, we know where the freezer is set, don't we? Okay? But what if I leave it in there longer? What if I leave it in there for like a month? We've already suspended belief all day today, right? We know that it's not going to explode. Okay? What if I leave it in there for a month? Won't it get below 30 then? Why not? There's no way it can get colder unless you turn it down, right? Unless you set it colder. That's the only way. Okay? Any questions about this?
Nope.